right, our topic for today is something called neutralization reactions. And so this is another application of acids and base. And the reason we're talking about neutralization reactions is because this is what you need to understand in order to do something called a titration. And a titration is something where you take an acid and a base and you mix them together and that solution gets neutralized. But then at the end of that titration, you can do use the data to figure out the unknown concentration. So that's where we're leading to. But for now, we got to review what a neutralization reaction is, because otherwise you do the titration, you're just randomly mixing things together, you don't really know what's happening. So let's talk about neutralization reactions today, and then later we'll talk about titrations. So the definition of a neutralization reaction is you take an acid and a base and you mix them together. And the reason it's considered neutral is because if you think of neutral, neutral means no charge, right? And so a neutralization reaction means you're balancing out charges. Because remember, in general, acids are things that have H pluses and bases are things that have OH minuses. So you're taking the H's and balancing them with the OH's, and then that's why you end up with something that's neutral. That's where that idea comes from. All neutralization reactions are known as double replacement reactions, which gives us a chance to review what that means. A double replacement reaction means that two things are switching spot. So it means that the ions switch partners. So whatever the positive and negative originally were, they are going to go with the opposite positive and minus. So and so that happens every single time. So that means that there's two products in a neutralization reaction every time. They are water and some type of salt. And by salt, I really just mean an ionic compound. All right, that's what I mean by salt. I don't mean NaCl every single time. I mean that it's some type of ionic compound where there's a plus and a minus balancing each other out. That's it. That's what neutralization reactions are. So let's go ahead and practice we'll do one together and then you'll practice some on your own. So here's the steps that you're going to do every single time, all right? You're going to start with whatever your acid and your base are. Your acid, sometimes I will give you, or you might just know what it is. Like hydrochloric, well, that hydro kind of sounds like H, and you would be right. Chlor kind of sounds like chlorine, which is a -1 because it's one away from the noble gases. So hydrogen is +1, chlorine is -1. So when those come together, hydrochloric acid is HCl. Plus calcium hydroxide. Calcium, if we look at our periodic table, calcium is Ca. It's got a +2 charge because it's 2 away from being balanced. So calcium is +2. Hydroxide, remember, is OH minus. That comes from our Pete sheet, or maybe you've kind of got it memorized because we've used it a lot. So if that's a +2 and that's a -1, I need more hydroxide to balance it. So then that ends up being 2 OHs and 1 Ca. So the formula for your base looks like that. Okay, hydrochloric acid, calcium hydroxide. So correct formulas for acid and base. We've got it. Now, the definition of neutralization reactions say that the ions switch partners. So H is going to now take the place of Ca, which means it bonds with OH. Ca takes the place of H, which means it bonds with Cl. Well, that H from the acid and the OH from the base form water, and we're going to write that as HOH. Because again, the H plus broke off from the acid, the OH broke off from the base, HOH makes water. Then the leftover pieces are Cl and Ca +2. So I've got Cl with a -1, Ca with a +2. Those are the two leftover pieces to make your ionic compound or your salt. But remember, I always write the positive one first, and this isn't balanced yet. This is a 1, this is a 2, so that means if I have another chlorine, now that -2 balances out that +2. The formula for my salt becomes CaCl2. So I've got my starting two chemicals. I know that it's water and salt every single time, so now let's start to make that look like an equation. So here we go. I start with my acid, HCl, plus my base, which was CaOH2, arrow, because those are my two reactants, so I need my two products. Water is HOH, and then my CaCl2 for salt. So acid, base, water, salt. Use that as your guide. It will always be that format. Acid with the H, base with the OH, H and OH break off. You're left with HOH for water. Whatever is left over is now your salt. Balance the charges like we did here, but then we got to balance the whole equation now. And I recommend you always start by looking at your salt. That will help you balance it really fast, because if I look at this, my CAs are fine, but my CLs are not fine. So I balance that. I need more on this side, so I put a 2 in front. Now there's 2 CLs. But now there's 2 H's right here, and there's only 1 H right there. Well, I can fix that by putting a 2 in front. Now there's 2 H's, but there's also 2 OH's. But 2 times OH, we're good. So now here's your balanced equation. Acid, base, water, salt. When you balance it, start with your salt and work backwards from there. So I want you now to practice some of these on your own. So there's 3 more examples down here. You can see them here. So in this case, I give you the acid. You figure out the base formulas. That's where we start. Pull off HOH. The H comes from the acid. The OH comes from the base. That makes water. Whatever is left over after H and OH are gone, that makes your salt. Balance them out and then balance the whole equation. All right? So remembering that every single time it is your acid plus your base equals HOH and whatever the salt is. And the salt is your plus and minus pieces that are left over after you pull out HOH. Because remember, the H is going to come from here. The OH is going to come from here. That makes your water. Whatever leftover negative is here and leftover positive is here, they come together to make your salt. And then you balance the whole thing. All right, thanks for listening.